All right, what's up, guys? We are doing the 6-4 practice classwork worksheet from Friday of last week when I was not in. So I just wanted to go through this one. A lot of the topics in here we'll cover that we went over during the week, and you can review this if you need to as you go along here. So, all right, page 1. First question is an altitude drawn to the hypotenuse. So remember, when you see altitude drawn to the hypotenuse, we are drawing out our 3 right triangles, and we're looking for similar triangles, and then we're creating proportions to solve. Keep in mind, we're looking for this side. We want to make sure we call that x. We label it with an x in the diagram, or we won't be able to do this question. We know that AD is 3, DB is 12, and we have the entire length of this side, which is 15. So I draw my chopped out right triangles, if you remember. We got the really big one. We got the medium sized one, and then we got the small mini-me looking guy here, right? So in the really big triangle, the only side we have is the bottom, which is 15. If you want to think of it, that's like A, C, B. And the triangle on the right angle is D, and then we have C, B going this way. So we have 12 as the long leg, which is this side right here. Okay, remember that this cuts it into a short and a long leg, so keep that in mind. X is the short leg. If it's a short leg in this triangle, X is the long leg in the other one, and then the short leg is 3. And so you should hopefully be able to see that I have these two corresponding sets of sides here, and apparently I have a red pen that doesn't work. So we have these sets of sides that we're going to pair together, and then I'm just going to do my proportion. So I can do, for example, from the same triangle, x over 12, 3 over x, or I can go from triangle to triangle. So we can do x over 3 is equal to 12 over x. And as long as when I cross multiply, even if you got a different proportion, the question is, when you cross multiply, do we get the same products? So x times x is x squared. 12 times 3 is 36. If you got that, your proportion is all good. We're going to then take the square root. Keep in mind that x is technically 2 answers here, right? It's 6 or negative 6. We are rejecting the negative answer because it's a length. So our answer here is just x equals 6. And so we know that CD is equal to 6. All right, that's our altitude drawn to the hypotenuse. Second question, we have similar triangles. So remember, with similar triangles, we know 2 things, right? We know that the corresponding angles are equal, and we know that the corresponding sides are congruent. Sorry, are proportional, not congruent. Meaning that there's some number you're going to multiply to get from one to the other. So in this case, my proportional ones are going to be the 2 A, B, D, E, and then B, C, and E, F. So we want to do a proportion. So if I do 7x from the first over 7, that's going to equal, going back to the first one, 4 over x. I'll cross multiply and solve. Or if you want to reduce here, you can do that as well. If we cross multiply, we're going to get 7x squared. We're doing the x times 7. And then equals 28. All right, we can divide out by 7 to get x squared is equal to 4. And then we're in the same boat we were in this top question, where I'm going to take the square root. I'm going to get 2 answers, but technically I only want to accept the positive answer because we're talking about a length. And so the length of AB, right, is the 7x. So AB is equal to 2 times 7, and AB is equal to 14. Making sure you go back and check that question, okay? All right, number 3, what we talked about before, similar triangles, right? In this case, their corresponding angles are congruent. So we have angle C, which is 4x plus 30, and G, which is 5x plus 10. These are corresponding. They're equal. So we just set up an equation, 4x plus 30 is equal to 5x plus 10. I'm going to take the 4x away from both sides first. Get the x's by themselves. Take away the 10. Oops. It's supposed to be minus 10 there. We get 20 is equal to x. Determine the value of x. That's all we needed to do. And so we're done with that question. All right. On to the next one. Number 4. Same idea. Triangles are similar. Sides are proportional. Okay. And this is important. This is what it's going to say on the exam. Only an algebraic solution can receive full credit. So if you're doing something like using the calculator or doing something to get the answers without actually doing the factoring, or you can even use quadratic formula that's algebraic, okay, you won't be able to get full credit. So we're going to do a proportion once again. So let's go from the same triangle. So we'll do this side, the left over the right. So x plus 2 over x. And then we go to the other triangle and do the same pattern. So it's the left side here to the right is equal to x plus 6 over 4. I'll cross multiply here, and I'll do 4 times x plus 2 is equal to x times x plus 6. We distribute 4x plus 8 is equal to x squared plus 6x. We notice, hopefully, that it's standing out. This is x squared is a quadratic. So I'm going to move the 4x and the 8 essentially to the other side. 0 is now equal to x squared plus 2x minus 8. We'll break out the diamond because diamonds are forever. Kanye West fans out there. We get negative 8 is, remember, 8 times c on the top. So the 1 in the front here times negative 8 is negative 8. The b is 2. Looking for two numbers that multiply to 8. Add to 2. So that would be 2 and 4. I need a positive 2. So it's a negative 2 times positive 4. Since this is a 1 in front, or essentially there isn't a number in front, we're just going to do our two sets of parentheses. X squared comes from the x times x. And then we drop in the minus 2 and the plus 4. We do our zero product property, set them both equal to 0, because if they multiply to 0, one of these two guys has to be equal to 0. So we get x is equal to negative 4. We get that or in the middle, because it can't be both numbers, or x is equal to 2. We're adding 2 to both sides here, right? So we are going to essentially reject this answer, because we can't have negative lengths, which means x has to equal 2. And we're looking for the length of AB, which is this side. So we know that AB is now equal to 2. Right. On to number 5. Find the measure of EH. So for EH, we're looking for this as x. Okay. So we know a couple things. Number 1, in our really big triangle, right? Once again, this is our altitude drawn to the hypotenuse. So we want to draw out our chopped out, exaggerated right triangles. Big guy, medium guy, mini-me, okay? In the really big triangle, I have a hypotenuse of x. And this is E here, H here, and J here, okay? In the triangle on the right, K is the right angle. The short side goes to J. The longer one goes to H. So you can see that this is the hypotenuse of 20. Okay. Oh, I forgot one over here, right? This side 20 is the long leg, so that should go over here. And then this side right here is the long leg. Remember, it cuts it down. This is short, that's long. So this is the 16. In the really small triangle, I really don't have anything. Technically, I do have the length of this side, EK. If this is x and this is 16, then this actually is x minus that 16. So keep that in mind for other questions that come up. You may have to do that. And what you should notice here is that we're getting these two corresponding sides here, so we can do a proportion. So I can do x over 20 is equal to 20 over 16. We'll cross multiply and get 16x is then equal to 400, right? 16 times x, 20 times 20. We will then divide out by 16, and I'll get 25. So EH is equal to 25. We'll call it a day there, okay? All right. A nearby tree casts a shadow that's 24 feet long. A nearby foot casts a 4-foot wall casts a shadow that's 4 feet long. So if we're looking at this, what we're going with here is that the sun is essentially at the same angle. So these two base angles here down at the bottom, these two angles are equal because of the angle the sun is hitting these should be equal. We also have these two right angles. So we have similar triangles, and then we can figure out the length of the height of the tree here. So once again, we have corresponding sides that are proportional. So if I do x over 4, then that's going to equal 24 over 6. And then we can cross multiply and solve again. can divide out as well and solve. It's up to you, but we'll just cross multiply and solve. So 6 times x is 6x, and then 24 times 4, 16 carry the 1 is 96. We'll divide it by 6 for ourselves. And we'll end up with a grand total of 16. And so now we know that the tree is 16 units, feet tall. And we're good to go. All right. Number 7, we have a flagpole. Flagpole. Right? Waving in the wind. With some stars and stripes. Good times. Okay. It's 40 feet tall. It casts a shadow that's 25 feet. If you're measuring the shadow, keep in mind you don't actually measure the distance from the flag to the ground. It's the shadow on the ground. So if this is the shadow of the flag, this is 25 feet long from end to end. Okay. And we have a building that is 200 feet tall. So building, obviously not drawn to scale up here, people. All right, building of terror. Okay. Shadow coming off of this building. Right? Same thing. We want to know the length of that shadow. So if we have the same concept here, the sun is shining down at the same angle, essentially. Okay. So here we go. The angle here is equal to the angle here. Okay. We have the right angles. We have similar triangles. We're going to do our proportion. So if we go 40 over, let's say 25 in the same triangle, we want to do the same order in this triangle. That's 200 over x. We'll cross multiply. So 40x is equal to, and then it's 200 times 25. So 40x is equal to, essentially, should be 50, and then 2 zeros, so 5 grand. About 200 times 25, which is indeed 5,000. We'll divide it by 40, which essentially means we cross out a 0 and divide by 4, and x should equal 125. All right? And so that is the shadow. So the shadow is 125 feet long. And there we go. Okay. And number 8, diagram shows a section of the city: Tacoma, High Road, Street, Main Street, parallel, 5 miles apart. Ridge Road is perpendicular to the 3 parallel streets. The distance between the intersection of Ridge Road and State Road, where the railroad tracks cross State Street, is 12 miles. What is the distance between the intersection of the Ridge Road and Main Street where the railroad tracks meet? Okay, so we're looking for distance between the intersection of Ridge Road, which is in Main Street, where the railroad tracks meet. Ridge Road to Main Street. Ridge Road to Main Street, that intersection right here. And where the railroad tracks cross Main Street, which is this guy right here. So this is the distance we're looking for right there. So what do we have? The distance between the intersection of Ridge Road and State Street, which is here, and where the railroad tracks cross State Street, which is here, this distance is 12 miles. So essentially what we have going on here is this 2 sets of triangles, right? We have this triangle formed by Ridge Road, Main Street, and the railroad tracks. You guys see that really big triangle. And then we have the triangle formed with the State Street part right here, the smaller triangle, okay? And so what we're trying to find here is we have these 2 triangles. They're both having right angles here, okay? And they're both sharing this angle, so they're similar triangles again. So if you see in this triangle, we have the length of 5 on the bottom. This height here, distance between ridge and the intersection of the railroad track here, is 12. We also know that the length of the Ridge Road between High and Main here is actually 10, and this is, we're looking for this side. So really, essentially what we have is we have a triangle that looks like this, with a distance of 5 and 12. And then we have another little bigger triangle over here where we have this is 10, and I don't know what this is, right? And you can do the scale factor thing and say like, hey, look at this, it's twice as big, so that's got to be twice as big, and get your answer that way. Or you can just do a proportion like 5 over 12 and then 10 over x, right? So we're going to have 5x is equal to 120. We'll divide by 5, and we will indeed find out that this is indeed equal to 24. And so now we know what the final answer is here. So, all right, and it does ask us for the distance. It's in miles, so we would say the answer is 24 miles. I'm going to include those units. All right, number 9 down at the bottom here, find the measure of GF. So, wait for that to stop bouncing here. We have a length of 25, we have a length of 16, and then this becomes 9. Keep in mind, this is the hypotenuse drawn altitude to the hypotenuse. So as this hits, it's creating a short leg and a longer leg. Okay, so we can identify what the sides here are. Now we also have our 3 triangles, so we're going to draw them out. We got the really big one we started with. We got the medium-sized one, and then we have the mini-me down at the bottom here. Okay, so we have E, G, F going on here. We have sides of x and a hypotenuse of 25. In the medium-sized triangle, right, the right angle is H. The short leg kicking out here is G, and then the long leg that sticks out here is E. And so we can see that all we have is this longer leg, which is actually 16, and we don't have anything else. Okay, and then we're going to drop down to the smaller triangle. We have H here. It kicks out to F, to the short leg, and then G going up to the longer leg here. And so what we have is we have 9, which is the short leg, and we have a hypotenuse. The right angle's over here, so across is x. And so as you're looking, you should hopefully see that we have these pairs of sides again, and so we can do a proportion. So 25, same triangle, over x, jumping up here, and then picking it apart, we have the same corresponding side to start with, so it's x over 9, and then we'll just cross multiply. So 9 times 25 is going to give us, let's see, it's 200, so 225, I believe, is going to equal x squared. We'll take the square root of that, which does come out to be 15. Remember, there isn't also a negative 15 that we are rejecting because we're talking about lengths here, and we should be good to go. All right, and that is the measure of GF. And just double check that that's exactly what you're actually looking for, and then you can go ahead and state your answer. All right, jumping onto the last page here, we have number 10. Jessica is walking her dog, notices the shadow is 4 feet 6 inches long. All right, and that she is 5 foot 3 inches tall. Her dog is 2 feet tall. What is the length of its shadow in inches? So once again, as soon as it mentions that we want the answer in inches, we need to start converting everything into inches, okay? So 4 feet 6 inches. Remember, every feet is 12 inches. So it's 4 times 12 plus another 6 inches, right? So this is really 48 plus 6, and that's going to equal 54 inches altogether. We have 5 foot 3, so it's 5 times 12 for the 5 feet, plus an extra 3. 5 times 12 is 60, plus 3 gives me 63 inches, okay? And so I have those two measured out. The dog is 2 feet tall, which is really 24 inches, right? 2 times 12. And now I have everything converted into inches. So what we have going on here is the same concept, right? You have Jess out walking the dog. We're just going to do dog here because my drawing skills are sad. All right. And we know that she is 54 inches tall. Okay. We know that her shadow going out, I don't know. However you want to draw this. Let's go this way with it. The sun's behind him, so the shadow's going over here. It's a real thin shadow because she's also pretty thin there, you see. So we want to know the length of that. And we know that the shadow is, ooh, careful, look at this. Caught it. Her shadow is 54 inches. And really what's going on here, if you think about it, is Jess is standing here, right? Her shadow is making that distance. So the sun coming down is creating that right triangle. And then her dog, right, has a shadow also coming off of it. And so we have another right triangle. And we talked about the angle of from the sun here shining should essentially be the same. And we should be good to go. So her shadow is 54 inches. She is 63 inches. Her dog is 24 inches. We want to know what that is. And so once again, we can do a proportion. So 63 from the left over 24 from the right triangle. And I just keep switching it up because I want to make you guys aware that there's different proportions you can do. So don't get confused or don't feel like you're doing it wrong if you get something other than me. Check your product for the next part. So 63x. And as long as you did it where you ended up with the same cross multiplication here, right? The same cross products, product of the mean, product of streams, that thing, you get this answer, it's the same. We'll divide out by 63, and we'll get x is equal to, and it says, let me check this again. Five to 3, 5 to 12, 60, 60, 63, 48, 60, 54, 3 times 24. I'm ending up with 20.5714, 2857 inches tall. So that's what I'm getting for right now. If there's an edit, I will come back and let you know. But that's what I'm getting for that question. Okay. Number 11, we have another altitude to the hypotenuse question. So we are going to draw out our 3 right triangles again. So just keep in mind, I'm making mine look exactly like the original, except I didn't do a very good job of doing the different sizes here, but that's okay. Now we're looking for the length of JK, which is this side, so make sure you call it an X. And I also know that this whole thing here is 15. So in the really big triangle, I have X, the short leg, 15, the hypotenuse, small triangle, or the medium-sized triangle over here, we have 12. Remember, this cuts this into a short leg and a long leg. Okay. Small triangle, I have 3 and a hypotenuse of X. And so once again, we have our corresponding sides set up. And let's go from top to bottom here. So 3 over X, and then we have X over 15. So as long as you're doing this and you're cross multiplying and getting X squared equals 15, 45, you should be good to go. Now we're going to divide this out. Keep in mind, simplest radical form. Remember on the graphing calculators, if you press menu, so once again, we need to be in calculator mode. We're going to press menu, M-E-N-U, the 2 and then the 3 button. Those are the keystrokes you want. That'll bring up factor, right? It says factor, parentheses. It's terrible. It says factor. You type in the 45 and hit enter, and it's going to spit out your prime factors. So it's going to say it's 3 squared times 5. And so what that tells you is that this is equal to 3, 3, and a 5. There's your set of 3s. That's coming out. And then 3 radical 5 is my simplest radical form answer. All right. Going on to the next guy here, number 12, Scalene Triangle ABC is similar to triangle DEF. I'm drawing a picture. Drawing myself a triangle, calling the vertices ABC. Whatever order I decided I was going to use for the first one, I'm going to use the same order for the second one. So D first, because that's where A went. E is where B should go. And then F is corresponding to C. So is AB over BC. So this is like left to bottom, right? And then this is DE over EF. That's left to bottom. That's true, and we're looking for false. So that's out. Now it's AC to DF, so it's right to right. Okay? So right to right. And then BC is bottom, EF is bottom, bottom to bottom. So this is also okay. It's the same order, so from jumping from one to the other. So that's out because we want false. Is angle ACB, which is this angle right here, the same as DFE? It certainly is. Those are corresponding, so that's out. And the other one is ABC, which is the one on the left, equal to EDF, the one at the top. It is not. Those are not congruent. So this is the one we're going to choose, which is choice 4. All right. Number 13, an easy one, an angle question, same thing, gives me similar triangles. I draw my picture, I label ABC. I draw a little smaller or bigger guy, just a little different size. I label Z where A is, X where B is, Y where C is. I know A is 50. If the triangles are similar, that means the corresponding angles are equal. So Z is 50. If C is 30, so is Y. And then X has to be, I don't know, and it's got a triangle here. So really, we're just finding this missing angle. So I know that these are supposed to add to 180. I have 80 degrees already, and I should get 100. So angle X is equal to 100, and you're good to go. All right, guys. Hopefully that helped you out. And good luck. Remember, we have a quiz on Monday. Just make sure you know how to do the review sheet. Should be good. See you guys later.